So in our previous class, we have discussed about different parameters of the flexible pavement. Now let us further discuss about the design component of different layers. And after this discussion, we'll try to design one flexible pavement with the help of the IRC 37 code. Now, if we discuss about a different component of the flexible pavement, so first component is the subgrade layer. And if your subgrade is not strong enough, if you have to provide one additional subgrade course, in that case, that subgrade portion must be compacted to 97% of the dry density. And this 97%, at least 97% of the dry density is achieved by mixing the soil particles with the adequate moisture content. And that moisture content is related to the maximum dry density and it is called optimum moisture content. So in the field conditions, if you do not have any idea about the So there are is there any problem? Hello, anybody is available?
Yes, sir.
Somebody messaged me that there is one election from Arunachal Pradesh and requested me not to continue the class. So is there any election or is there any issue with you? Okay, I am continuing the class. So whoever is from Arunachal Pradesh, I'll give their attendance. So is it okay? Okay, I suppose nobody is present. So this subgrade should be compacted to 97% of the dry density, and this dry density is achieved by mixing adequate portion of the water with the soil particles, and that adequate portion of the water is called optimum moisture content. Now, for this reason, you might have seen that before compacting the soil over the road surface, and that is compacted by roller, some water is sprinkled over the soil particles, and that water sprinkler is carried out to attain the maximum dry density. Now, for expressway or national highway and state highway, the material used for the subgrade should be of the dry density not less than 1.7 gram per cc. So you have to find out after the compaction and after each and every step, you have to collect the material from the separate portions, and you have to find out what is the dry density of that particle, and that dry density should not be less than 1.75 gram per cc. Now, for determining the Cpr value, the standard test procedure described in IS 2720 should be strictly adhered to. So, you know that Cpr test is conducted to find the subgrade strength. Now, this Cpr test should be conducted as per the instructions given in IS 2720. So about that Cpr test we have already discussed. So after we complete the syllabus, we will discuss all the tests along with some video lectures. The test must always be performed on remolded samples of soils in the laboratory, that is for the Cpr test, and it is recommended that the samples be soaked in water for 4 days prior to testing. Now there are two types of Cpr test, all of you know. One is soaked Cpr test and another one is unsoaked Cpr test. Now for the soaked Cpr test, that test is performed in the area where where the zone is under the heavy rainfall area. Okay, if the area is under heavy rainfall zone, in that case, the Cbr test you have to conduct it is the soaked Cbr test. And for the dry or arid regions, the Cbr test you have to conduct, that is the unsoaked Cbr test. And in situ Cbr test is not recommended because basically Cbr test is a laboratory test and you have to perform the Cbr in the laboratory only. So after that, next course is sub-base course. Now for the sub-base course, it is also called granular sub-base course or GSV layer, and this material conforming to clause 401 of MOT. MOT means Ministry of Road Transport Authority of India. Their specifications for road and bridge work is recommended. Now, the sub-base material should have a minimum CBR of 20% for cumulative traffic up to 2 MSA. MSA means Million Standard Axle, and 30% for traffic exceeding 2 MSA. The material should be tested for CBR at the dry density and moisture content expected in the field. The thickness of the subbase should not be less than 150 mm for design traffic less than 10 MSA and 200 mm for design traffic of 10 MSA and above. Okay, so that is the thickness. So if your design traffic is less than 10 MSA, then 150 mm thickness is required, and if it is more than 10 MSA, in that case 200 mm of the thickness is required. And in such cases, the Cbr value of the subgrade must be above 2%, and if the Cbr is lesser than 2%, the design should be based on Cbr of 2% and a capping layer of 150 mm thickness of material with a minimum Cbr of 10% shall be provided in addition to subbase, and that particular layer is basically called compacted subgrade. Okay, so if your subgrade course doesn't have adequate Cbr value, suppose your subgrade course has a Cbr value lesser than 2%, In that case, you have to go for the design considering the 2% Cpr test, but in that case, you have to uh, add one additional layer of compacted subgrade for which your Cbr value must be over 10%. Where stage construction is adopted, the thickness of subbase shall be provided for ultimate pavement section for the full design life. So next portion is base course. So the recommended minimum thickness of granular base is 225 millimeter for traffic up to 2 MSA and 250 mm for traffic exceeding 2 MSA. So for heavily traffic roads, okay, if there are heavily traffic roads, use water bound macadam. It would be WBM, water bound macadam base laid by paver finishers or motor grader is recommended. So if there is expected for a heavy traffic, in that case water bound macadam should be adopted, and over this some paver layer, some bituminous layer must be there. Where WBM construction should be adopted in the base course for roads carrying traffic more than 10 MSA, the thickness of water-bound macadam shall be increased from 250 mm to 300 mm. So after that, our main course, that is bituminous surfacing course. The bituminous surfacing course, it shall consist of either a wiring course or a binder course with a wiring course depending upon the traffic to be carried. So there are different layers of the bituminous surfacing course. It is categorized as wiring course. It is, and beneath this there is a binder course. And the thickness of the wiring course and the binder course will depend on the traffic conditions and the rainfall conditions over that area. Now, the selection criteria for the grade of bitumen to be used for bituminous course are given in the below table. Okay, so if the climate is hot, in that case, your traffic, for any type of traffic, your bituminous course should be bituminous macadam, and grade of the bitumen to be used is 60 to 70 grade. So, for example, these are the different climatic conditions, and based on the climatic conditions, you have this type of bituminous grade, different type of bituminous grade. Now, column 2 and column 3, that is not required for you, because these different types of bituminous courses is not included in your syllabus. You have only the basic portions. So you just need to know about the different climatic conditions, and based on the different climatic condition, what type of grade of bitumen should be used over here. Now, where the wiring course adopted is premix carpet of thickness of up to 25 mm, thickness of surfacing should not be counted towards of the total thickness of the pavement. Now, over the wiring course, there must, in some time, there may be some surfacing course or some seal coat or some prime coat. So that coating portion should not be counted as a total thickness of the pavement because that portion do not contribute to the structural strength of the pavement portion. Just wait a minute. Let us solve one problem. Okay, I don't know whether you have IRC code or not. So you can write it down. Okay, the severe value of subgrade soil is 5%. Calculate total thickness of a pavement using, that would be your second one, design chart recommended by IRC, that is Indian Road Congress. So basically IRC method, that the method followed by IRC, that is basically based on the severe value of the different layers. So based on the severe values and the traffic over that area, we will calculate the future traffic, and after that there are some design chart based on the severe value and the traffic in million standard Excel MSA. So based on these two chart, we will directly we can directly find out what is the total thickness of the pavement and consecutively the thickness of different layers. So here assume 4100 kg wheel load or medium light traffic of 200 commercial vehicles per day for design, and tire pressure is given as 6 kg per centimeter square. So this is the value. So first thing, first is you have some equations. From that equations you have to find out what is the total expected traffic after the expected design period. So number of vehicles, that is the formula, number of vehicles for design is given by P into 1 plus R to the power n plus 10. Okay, there is some error in the data. Have you wrote down that for numerical? Just write it down. The Cbr value of subgrade soil is 5%. Calculate total thickness of a pavement using design chart recommended by IRC. Just write it down. And remember two things, that Cbr value is 5% and your total traffic is 200 commercial vehicles per day. Okay. So you have to go for the IRC design chart. So if you have the IRC code, you can find out the chart. Otherwise, see the chart. This is the IRC design chart. Okay, so you will get this chart in the IRC manual, that is IRC code 37. So in that case, see, these all values are the depth of the section in centimeter. This is the California bearing ratio test, and these are the different traffic load. Okay, so here traffic load is 200 commercial vehicles per day or medium traffic. Okay, or medium traffic. So that is also mentioned in the question. So for the medium traffic, that would be your curve. Okay, the middle one is your curve, and your CPR value is given as 5%. So for the 5% CPR value and for the medium traffic, your section would be like your 38, yes, 38 centimeter. Okay, so this is simple. So just you have to read out the curve where the California bearing ratio values are there and where depth of the section is there. And another curve would be there where it will mention different traffic conditions. So from that traffic condition, you select as per your convenience that is mentioned in your questions or that you have found out from the survey, and from that you just find out where or what is the total thickness of the pavement section. Okay, so by using this card you can easily find out what is the total thickness of the pavement. Okay, so see, it is written as 37.5 centimeter or nearly 38 centimeter. Now we have discussed about the flexible pavement design. Now there are different types of pavement failures which is very much important. So in terms of pavement failures, there are different type of failures. Okay, and these different type of failures are originated. Please write it down. The Cpr value of subgrade soil is 5%. So after you complete it, just let me know. Okay, I am again discussing the chart, how to use the chart. We see the question. This 4100 kg, that is not required for the IRC chart because that is for another method. Here another method is also mentioned. So as in your syllabus only Cbr method is there, so I will discuss only the Cbr method. So basically in the question it is given as your traffic load. Traffic load is medium. Okay, so for the medium traffic load you have to find out for the 5% Cbr value what is the total thickness. So if you go to this chart, in the chart the top portion is the California bearing ratio test value, that is the Cbr percentage value. In this portion, okay, that is the depth of the pavement section which you have to find out, and these curves represent the different traffic condition. Okay, so first one is for the low traffic condition, second one is for the medium traffic condition, and the last one is for the heavy traffic condition. So for the medium traffic condition, as in the questions you have to select that medium traffic condition. Now see, where is the Cbr 5% value? So this is 2, 3, 4, 5. So that is 5% Cbr value. So see here that 5% Cbr value, this 5% Cbr value is intersecting the traffic curve over here, okay, over this point, and in that case you just have to draw another line over there to find out at which point it intersect the depth of the construction curve. So here you see 0 is starting from here, so 0, 10, 20, 30, and it is around 38. So your total thickness of the pavement would be like 38 centimeter. Is it clear? So if it is clear, so we'll conclude our class right now. So I will suggest you to just download the IRC code, okay, and just go through all the notes, that is the previous notes, and today's note, that is the how to design different section. So whatever design today we have discussed, yes, you can get it from the internet. So whatever portion we have discussed today, okay, that is the total thickness, design of the total thickness, that is very basic portion. So in the next week we will discuss that how to design different portion or different layers of the flexible pavements.